The audio editor is the core of sound modding in Enfusion. In this little video, I'm going to cover the very basics and everything we need to create our first sound. Most likely, our audio editor will look very empty on the first startup. To change this, we can navigate top left to Window and open the elements we need, or simply press F1 to F9. Starting with the left side of the screen, we see the resource browser. Its top shows the folder hierarchy of a project, and the bottom part shows the contents of the currently selected folder. The output tracker displays the continuous waveform of everything that is being played. The log console displays warnings and other useful information. The listener setup allows us to move around our sound source within the editor window. The master level monitor displays the current audio output. The item detail window lets us edit the specific attributes of each node, and the node selection allows us to insert nodes into the scene. Alright, let's create a simple sound setup with the most basic nodes. First, we need to create an ACP project file. We can do so by either clicking on File, then New, and then Project, or just by using Ctrl, Shift, and N. We start off with a bank. It can be viewed as the heart of most ACPs, because it is the place where our samples are stored in the WAV format. Banks also allow us to do some basic editing of the sound's playback, such as volume, pitch, and even things like adding silence before the sample. To create and fill a bank, we can click on Bank Local at the node selection and add our samples at the bottom of its item attributes. A quicker way is to just drag and drop one or multiple sounds from the item explorer into the scene. Easy. We can also add sounds by dragging them onto the existing bank, and we can replace all sounds of a bank by holding Shift while doing so. Please note, just putting our sound files into the project folder is not enough. Like all files in Enfusion, they have to be registered. To do so, we can select our new files in the resource browser, then right-click and choose Register and Import. Next up, we got the shader node. Aside from having an input for DSP effects, it is the place where we handle the spatialization as well as the volume and frequency attenuation of our sounds. Or, in simpler terms, it is responsible for the basic handling of how our sound behaves with increasing distance. The shader node itself doesn't have many attributes. Instead, you might have noticed the input ports. Each aforementioned property, spatiality, volume attenuation, and frequency attenuation, are handled via dedicated nodes, which are then connected to the shader node. We start with the Spatiality node. It handles how much the sound either plays back 2D or from the location of the sound source. By default, it's set to use a static value, 0. This means it is 0% spatialized and will always play back in 2D. Changing it from 0 to 1 will make it 100% spatialized, meaning the sound will play back in the world from the source position. We can also, for example, set the spatial factor source to curve. This will allow us to use the curve editor and add a dynamic blending between 2D and full spatialization depending on distance. To do so, we click the Edit button, which just appeared. The curve editor displays the distance on the x-axis on the bottom and the spatial factor on the y-axis on the left. We can now simply double-click anywhere to create a new point, then drag it to where we want it. Dragging it to the very lower left reads as follows. At a distance of 0 meters, the spatialization will be 0%, meaning it will play in 2D. Let's create another point and drag it to the upper right corner. It reads as follows. At a distance of 1 meter, the spatialization will be 100%, meaning it will play from the source position. In between these 2 points, the spatiality will smoothly interpolate. So at half a meter, spatiality will be 50% in this example. We can also use the input boxes on the top of the curve editor to precisely manipulate the position of our points. The graph will automatically resize. Next up is the Amplitude node, which handles the volume attenuation over distance. We can choose between different curve models, of which all give us at least an inner and an outer range. The sound will keep the same volume up to the inner range and then fade out until the outer range is reached. We can also select the custom curve in order to create our own volume attenuation curve in the curve editor, which we looked at before. The last shader-specific node is the frequency node, which handles the loss of high frequencies over distance. The most important checkbox here is Enable Distance Attenuation. When enabling it, we can choose between either programming our own low-pass filter or using Enfusion's air absorption filter. I highly recommend using the latter, especially if you want to make sure your sounds blend in well with the base game. The air absorption filter is an approximation of real-life high-frequency loss over distance, and almost all sounds in Reforger make use of it. Now that we know what all these nodes do, we have to connect them to where they belong. To do so, we can simply hold-click on one of the node's ports, then drag it to the port we want to connect it to. Alternatively, we can hold Alt and then just click on the 2 ports we want to connect. While we're at it, we're also going to connect our bank node with the shader node. One of the last nodes we're going to have a look at is the sound node. The only thing we need to know for now is that this is the node which the game uses to trigger sounds. Let's say we write a script and tell a prefab to play the sound shot. This will cause the game to search through all connected ACPs and look for a sound node that is called sound shot. If it finds it, the sound will be played. Therefore, the sound node is the only node in which the name attribute really matters. I recommend starting the name of every sound node with sound_, just for the sake of making clear what it's used for. The last node we'll have a look at is the mixer or OutputState node. In an ACP, it is a reference to the actual mixer file and will appear as a node with all mixer channels represented as an input. It can be found in the Sounds folder of the Reforger data and is called Final Mix. Please note, very important, we have to select the Final Mix via the resource browser, not by using the Mixer Node button. The Mixer Node button is meant for creating a new mixer file. Once the mixer is in, all we have to do is to connect the output of our sound node into the mixer input, which corresponds to our sound the best. And there we go! This is everything we need in order to create a simple sound which is properly attenuated and spatialized over distance. We can now click on our sound node and press the spacebar in order to preview the sound that we just created. We can also use the listener window in order to change the position around the sound and check how it behaves over distance, for example. Those were just the very basics, and there is a ton more to be covered, which I might do in a follow-up video. Just to mention a few important things already. We can enable additional ports on some nodes, like the pre-silence and offset ports on banks. We can create constant nodes and fill them with static values, which can then be used to be fed into other nodes. We can create so-called signals, which allow us to interface with the game and create complex logics to influence our sounds in real time. We can insert filters, or DSP effects, in order to apply DSP effects to our sounds in real time, and much more. But that's it for now. So, thanks and have a good one.